Recurring decimals, paper 3H, iGCSE, November 2008, and this is question 17. This question involves changing recurring decimals into fractions. Let's start with part B, part A. So, 0.0y recurring is a recurring decimal, where y is a whole number, such that y is between 1 and 9. So this is like saying, let's have something like 0.01 recurring or 0.04 recurring as a decimal and see what the rule would be. And we can just call it y because we're going to look at the general rule. Part A had us writing 0.07 recurring as a fraction. So let's make x equal to 0.7 recurring. So then we'd multiply that by 10 and multiply it by 100, and 100x would give us 7.7 recurring, and 10x would give us 0.7 recurring. This means that we can take one from the other, and all these 7s after the decimal point effectively cancel each other out. So that gives us 90x equals 7, so x equals 7 divided by 90. So we're going to do exactly the same thing for our algebraic example. So we're going to multiply it by, our x is 0.0y recurring, so we're going to multiply that by 100 and by 10. So 100x would give us y.y recurring, and 10x would give us 0.y recurring. We then take one from the other to give us 90x equals y, just like 90x equals 7 in the 0.07 recurring example. Divide one from the other, so as our x is equal to 0.0y recurring, that will be equal to y over 90. Let's just go back to our original example, and you'll see it's got exactly the same structure. So we had 110 and 90, and then we end up with y over 90. So if 0.0y recurring, well, this one would be 7 would be equal to y, and then we'd have 7 over 90. So this just shows us a general rule. So if we had something like 0.05 recurring, then we'd have 5 over 90. Or we had 0.06 recurring, then we'd have 6 over 90. Okay, so let's have a look at part B. Part B is very similar. We've just got one extra sort of a layer now. So we have 0.1y recurring is also a recurring decimal. So we're going to have a look at part 1 and see how we would convert this as simply as possible. So x is equal to 0.1y recurring. Let's have a look at an example with numbers in. So we'll keep with the 7. So we had to write 0.17 recurring as a fraction. Again, we'd multiply by 100 and we multiply by 10. That in this example would give us 17.7 recurring and 1.7 recurring for 100x and 10x. We then take one from the other to give us 90x equals 16. So although all the 7s would cancel out, that would give me 17 take away 1, which is 16. So x is then 16 over 90. So let's do exactly the same thing now, but instead of 7 we'll have y. So let's multiply it by 10. That gives us 10x is equal to 1.y recurring. And then this bit's a bit more complicated. This is a bit that will probably trip you up in the question. So 100x is equal to, essentially, like a bit like 17, it'd be 1y point y recurring, but that's the tens and the units. And although that makes sense for multiplication, it doesn't quite make sense for algebra. So let's just split out that 10 and make it 10.y recurring. Otherwise it just looks like 1y. Okay, so now we can do the same as before. We take one from the other, so that will give us 90x. All the y's after the decimal points will cancel out, so now I need to do 10y take 1. Well, 10y take 1 is 9y. So now we can divide one by the other, so then x, which was equal to 0.1y recurring, will be equal to 9 plus y over 90. Let's just go back to our number example. So we had that x was equal to 16 over 90. Well, if you have a think about 16, that's 9 add 7, and the 7 in this example is y. So you can see how this is the general rule. So if we had something like 0.14 recurring, then we'd have 9 plus 4, 13 over 90, and that gives the general rule.